Okay, so we have our math boxes out today, and what we're doing right now is we're working on finding all the factors. So we want to find all the factors for 20, and then we're going to circle those factors that are prime. All right, guys, keep working on those. Make sure you find them all. Roger, what's the first factor pair for 20? Very good. Oh, 1. We have 1 and 20. What's the next one? Oh, can't be Blake. He's not here. Ava. 2 times 10. How did you do it? Okay. Half 20 and double 1. Very good. Hey, we went 1 and 2. If Danielle was here, it'd be funny if we got 3, but I know 3 isn't in here. 13. That up. He is not in the room right now either. Braden, you were the next one. And Danielle isn't here, so it was like we went right up our numbers. Isn't that funny, class?
Yes.
Yeah. Braden, what's the last factor pair for 20? 4 times 5. Good job, buddy. So let's check and see if we're right. You guys did it. Now, if you look, they're circling the factors that are prime. So it's like you're finding factors within a factor. 2 is prime because the only way you can multiply and make 2 is 1 times 2. And 5 is prime because the only way you can multiply and make 5 is 1 times 5. So then 20 isn't prime. Now 1 doesn't come as prime because 1 only has 1 factor. 1 times 1. You have to have 2 factors to be prime. Can you have more than that? No, you can't. But 20 isn't prime because you can do all of these to get 20. 10 isn't prime because you can do 1 times 10 and 2 times 5. And 4 isn't prime because you can do 1 times 4 and 2 times 4. See if you can find the factors for 24. Who needs more time? Okay, we're just going to find them on the side and then we'll check the answers afterwards. So how about telling me the first factor pair, Macy? How did you know? Very good. One's a factor for everything, and it's just matched with that number. Parker, what's our second one?
2 times 10. 2 times 12.
2 times 12. How did you do it, Parker?
I know that 24 is even, so that means 2 halves 4, and they split. So if you double a number, you have to half the other one.
Very good. We knew that 24 is even, so 2 will always work. You just have to double in half. Delia, will 3 work? Okay, but Delia, what 2 numbers make up 24? Add those together. No, try that again. You multiply them. Add them together. 2 and 4. Good. 6.
Good morning. Today for lunch, red, barbecue pulled pork on a bun, blue, beef soft shell taco, tater tots, fruit and veggie bar, milk variety. I do want to make one birthday announcement today. Eli Flitton, happy birthday, Eli. I hope you have a wonderful day. We do have 2 questions for today. First one is, how do you know when Santa's in the room? How do you know when Santa is in the room? Well, it's because you can sense his presence.
Oh.
The next one. Why did the elf go to school? You better get this one. Why did the elf go to school? To learn his alphabet. All right. One more announcement from the office this week, with our food drive. This year we brought in 300 pounds of food. Outstanding job from all of you. That's 35 pounds more than we brought in last year, 35 pounds more than we've ever brought in. So fantastic work. We appreciate all your help, and that will definitely help some families over this holiday. Have a wonderful Tuesday.
Okay, so Delia, you said 2 plus 4 is 6. Can you count to that by 3s? So is 3 going to work, Delia? Got to remember that trick. So 3 is going to work. I know it's got to be less than 12. Delia, do you have any idea 3 times what equals 24? Okay, 3 times 4 is 12. So it's got to be bigger than 4, but it's probably also less than 10. Because 3 times 10 is 30. Okay? 21. So 3 times 7 is 21. 3 times 8 has to be 24 because you're just adding another 3. It's like if I had 7 3s, it's 21. If I add 3 to it, 21 plus 3 is 24. That would be 8 3s. So it would be 3 times 8. Mackenzie, how about the last one?
4
Times. All about doubling and halving. We worked really hard on this like 2 weeks ago on a Friday where we found a lot of factors. We double and we half. We look right here because we know that 2 can double the 4, but it's not the 2 that's important. It's the
12.
So what do we do with that 12? We
Half it.
What is that, Mackenzie? Half of 12 is 6. Very good. Now here's a hint for you when you're looking for the prime numbers. Anything bigger than 2 and even is not prime because you can multiply by 2 to get there. And we know that 1 is never prime because 1 is its own thing that I'm not sure about. So the only 2 you should circle are
2 and 3.
Let's see if we found them all. Yay, we did it. Okay, with that, I'm going to pause the recording because it's about time for us. And we were working on finding all the factors for numbers. We're going to do one more before we start actual math. And we have Miss White today, so we have to be kind of efficient. So we're trying to find all the factors for 42. Now, please remember when you're doing this, 1 is the easiest one to find. 2 is a factor for every even number. Porter, what's up?
On the last screen, we didn't do
Yeah, I know. To find out 3, you add the digits and see if you can count to it by 3. Then you just kind of have to try things. After that, it's pretty much doubling and halving. So have at it. Good luck. 42, I'm going to give you roughly 3 minutes. You should write them down so that if I call on you, you can just answer. Positive self-talk to yourself if you have to. Okay, what's the first one? If you're still working, keep trying to go ahead here. Chase, what's the first one?
42.
Okay, and I usually like to go with the smaller number first because then I'm working, this side's always going to get bigger, this side's always going to get smaller till we meet in the middle. How about the next one, Porter?
3 times 2.
Good. I think most of us are pretty good at finding the first 2. All right, so how about 3? We've not been real lucky on 3 today. Hadley.
3 times 14.
How did you do it, Hadley?
Well, we took the number 4 plus 2 is 6, and if you count the 6 by 3s, so I know 3 is a factor, and then to get my 14, I did 3 times 10, which is 30, which is and then I did 3 times 20, and that was 60, so that was too much, and then I went to 15, and that was a little over, and then I made 14 with my answer.
You guys forgot this. Remember I did this with all of you a whole bunch of times? Then you think, how many more to get to 42? And you write down how many that is, which is 12. 3 times what is 12? 4. I've shown you guys that a whole bunch. How about the next one? What was the next one? Elizabeth. 4 times 10 and a half?
6 because you can split 14 in half and there's a 3.
Yeah, 4 won't work because 21 is odd. We have people not paying attention. So we're going to probably have some people having to go back to the computer in the back and take some dojo points. 4 won't work because 21 is odd. 5 won't work because this doesn't end in 5 or 0. So Elizabeth is right. The next one's going to be 6 because she said we can do what? Elizabeth, what can we do?
Half 14.
Yep. And then what would be the next one you would try?
7.
But it's already up there, so that means you're done. Now remember, if it's an even number bigger than 2, it's not prime. Also, 1 is never prime, right? So 6 is out. 14 is out. 42 is out. I know that 2 is prime. I know that 3 is prime. Because the only way I can make 2 is to go 1 times 2 and 3 times 1, right? The only way I can make those 2 numbers. 7 is 7 prime.
Yes.
Yeah, there's only one way to make 7. 1 times 7. How about 21?
No. No. Yeah. No.
1 times 21 and
7 times
3 times.
7.
There you go. Okay, we're still in our math notebooks right now. And here's your math message. It says, Lacey has 40 bottle caps. Donovan has 20 times as many bottle caps as Lacey. How many bottle caps does Donovan have? Be prepared to explain your answer. So you're figuring out this multiplicative comparison problem. Lacey has 40. Donovan has 20 times that much. How many does Donovan have? Go ahead. Needs more time. Excellent. Very good. Okay, so explain it, Braxton.
So I put down
the 40 and the 20, and I multiplied them. But so first,
Why did you do that?
Well, I mean, I just put down the equation.
How did you know you're supposed to do that?
Because he said, because times is who were like multiplication.
Yeah, it literally says 20 times right there. 20 times as many as Lacey. Lacey has 40, so you were right. Very good. Then explain to us how to do it with that weird equal sign I just wrote.
And then I took off both the zeros from the 40 and the 20, adding them to the end, and then I multiplied 2 times 4, and I got 800.
Okay? No, it's not necessarily better. It's just your way of doing it. So say that again, Braxton. You put both zeros at the end.
Yeah, and then I multiplied 2 times 4.
Which is?
8.
What's up? All right, lay it on us.
So I split the 2 into 10, so I know 10 times 20 would equal 400. So I just doubled 400, which got me to 800.
That is a good way of thinking about it. Braden.
No, I did it I did 2 times 4, then split 8, and then just added the 2.
So you kind of did it the reverse of Braxton and did the digits first. Oh, and then took these zeros at the end and put them back over. Also a good way of doing it. This is going to be kind of our skill that we're working on the rest of the way. We're working on extended multiplication facts. So let's get out. Let's get out Math Journal page 105. All right, so your page looks something like this. It says, write a multiplication fact for each fact triangle, then extend the fact by changing the first factor first to a multiple of 10, then to a multiple of 100. So if you look, this is a fraction circle, and what you do, or to me, a multiplication triangle, it's none of those things except for the last thing I said. And how these work are, if you just cover one corner with your hand, if this was a piece of paper, you would block one of them. So you would, and you always, this is, you're working, 2 times 3 is 6. Okay, so if you covered that up, you'd be doing multiplication. If it's down here, if it has the dot showing you divide. 6 divided by 2 is 3. 6 divided by 3 is
2.
Okay, so they gave you the original fact. 2 times 3 is 6. Solve the extended fact. 20 times 3. Autumn, tell us about the first one. You can come up and do it.
So what I do is I move up 2 times 3 is 6, and I have to add 1 0. So I have 6 total.
Okay. Good. What I like to do in Braden, there's nothing wrong with the way that you did it. If it works in your brain, that's fine. I like to do the digits first. Okay? Because then I just do 2 times 3, then I go back and count how many zeros are there. And maybe an example will show up for why I like to do that. Rajan, go ahead.
No.
No, I didn't.
And that's a 0. Yeah.
No, I didn't mess it up. I was telling you that your way of doing it, where you put the 0 down first and then do 3 times 2. I knew I was talking to you. That's why I was looking at you when I said it. I knew what I was doing.
I know, but there's something about like the name.
I probably wouldn't mix you up with Autumn. I'd mix you up with Braden because much closer. If you look, the first 3 letters are the same. They both have a Y, and they both end with an in sound. So that's why that probably happens, because they're similar names. But that's okay. That's just time we needed to explain why names get mixed up sometimes. Okay, the next extended fact. Maddie, come explain.
I know what 2 times 3 is, so I mostly just added 2 zeros to the end. So it would be 600.
Very good. Now again, the point I was going to make, I like to do the digits first, then put the zeros on. I'll explain why later. Hopefully we get a good example of that. So now we're going to look at the original factor. We're going to write it as a multiplication fact. We have, good help, 6.
6, 8.
6, 8. Not a times 8, just an 8. 6 times 8
equals 48.
Okay. Now, if we're doing the extended fact, what we want to do is we just want to add 1 0. So we're going to go 60
times 8.
Go ahead and solve. Braylon, come do the next one.
I did 6 times 8 is 48. All of them 48. And then I'll add a little bit.
Very good. Yeah, what's up?
Yeah, I think I understand what you're saying now. Because if you do, for some of the numbers, when you multiply, they can get like 5s in the middle, so then you probably want to do the digits first.
Yeah. Okay, now do that one. Okay, then I'll explain a reason why I think it's a good idea in a minute, okay? Okay, what would our answer be here? Hopefully we're picking up on this.
48,000.
4,800. Excellent. Okay, I'm not sure we need much more of that. Is anybody confused by this?
No.
Okay, then let's go to the next page. Okay, so now this one, they tell you that 3 times 5 is 15. Now they're asking 30 times 50. Go ahead and try that. The same basic idea, just this time there's a 0 on each of them. All right, this should be pretty easy. So it's the same basic principle. However you want to do it, if you want to do the digits first, you're doing 3 times 5 is 15, then count your zeros, you'd have 2 and you put them down. And if you did the zeros first, you put the zeros down and then do a 15. Either way, you're going to get the same thing. So now, if this isn't print, I would have liked to do the print one. Now they want you to do the same thing. Original fact. 4
times 6 equals 24.
And this time instead of, whatever, it's a 24. This time they want you to put a 0 on both of these. Like that. Go ahead and try that. Okay, so obviously, guys, what's the answer here? We know that we start with 24 and then we add
2 zeros.
Okay, is everybody okay with this? Doing all right? Great. Because I'm going to show you why I might do the digits first. And then inevitably somebody's going to disagree with me, and that's fine. You think you've got a different way. It's okay. Then you do it your way. Let's see how far I've got over on this board to work. Just the first 2. Here's why I would do it this way. So here's my triangle. Okay? See, the original fact is 8 times 5 equals 40. Now here's what kids do, and it's the same thing you were working on your math boxes yesterday, and you guys were just, I'm going to be honest, you struggled. I'm actually going to write my answer down here. We're at another one. And here's what kids do when they have the zeros first. 8 times 5 is 40. Then I should only have 6 zeros. That's what kids do. They go, and even if they do it right, if they do this is what they do. They go. Here's why I do it my way. Because I don't even worry about the zeros until I multiply. 8 times 5 is 40. I'm done with those. I haven't counted my zeros. All the zeros that are here have to come here. 1, 2, 3, 4, 5, 6. And now I can just pick it up and keep writing like a number. 1, 2, 3, 4, 5, 6, 3, 3, 40 million. You guys see why I do it that way? Because then I just count my zeros at the end. I write down what I get for an answer, then I write my zeros. So here we go. I'm going to show you another thing from yesterday that we've had some struggles with that is understandable. So let's say I have this. $360,000 equals 60 times blank. This is what I was trying to teach you. Here, let's even make it a 600. If I cross out a zero on this side, and cross out a zero on this side. If I cross out a zero on this side, and cross out a zero on this side. Whatever I do to one side of the equal sign, I have to do the same to the other. Now, I'm trying to think 6 times something equals, what do I have left? 3,600? I'm not going to do that. I'm going to think 6 times 6 is 36. 6 times 6 is 36. There are the 2 zeros there. Where would these 2 zeros have to go?
Right on the 6.
You guys see how that works now? You said no. Hey, look, Elizabeth. This zero is this zero. I crossed it out. This zero is this zero. I crossed it out. Then these 2 zeros are going to go here. 6 times 6 is, now watch. If I work backwards now, 6 times 6 is 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros.
The reason I was confused is because I thought you just gave me a 6 and 6 negative thing there, but you were multiplying 6 times 6 with 6.
You guys understand that?
Mm-hmm.
You guys need more of these?
No.
So let's look at math boxes. So maybe we have time to work before this light gets in here. Here we're looking for equivalent fractions. So I always like to work with the smaller one to try and make it into the bigger one. That to me seems to be the easiest thing. So I have a smaller denominator here. I think, what can I do to 5 to make it 10? Whatever I do to the 5, I also do to the 1. Basically, it's this for those of you looking at me confused. What can I times this by to get this? It's what we just did on our math test. And if when I go 1 times 5, there's going to be 1 times 2 and 5 times 2, if it equals 2/10, then it's equal. Now, what happens when you have, like, I can't make a 4 into a 6? Then you do this. 1/4 equals 2/6, and you multiply them both. Now, sometimes you have to just flip-flop the denominators. But this time I'm going to show you a special trick. I know I can turn 4 into 12. How do I do that? I can turn 6 into 12. How do I do that? That would give me common denominators if I solve them. But some of you don't like to write things down. You just like to do them in your head. And guess what? It's not wrong. It's harder to do. You guys understand how to do that? You're also going to probably need to think about that for letter D. Solving using US Traditional addition and subtraction. Doing C and D. I need to see work. I need to see work. Questions? Has everybody crossed out A and B and circled C and D so you know you're doing them?
Yes.
Braylon? No, because then I can't see it. It would be really nice if you did. Or if you're going to do that, include it so I can at least look at it. This one's about place value. They're telling you the value of the 7 on the left. So if I'm looking at this, this is the 7 on the left. 7 on the right is this one. And they want to know how many times larger is this 7 than that 7. We've literally done this about 8 times, and I've gone over it at least 6 or 7 times. When you move over one place value, like if I move this 7 from the tens to the hundreds, I would have to do something to it. And then if I move in another place value, I have to do that same thing again. Okay, I'm going to write this down for you. I'm going to go this way. 1 meter is 100 centimeters. 1 centimeter is 10 millimeters. Yeah, time to do number 5. Questions, comments, or concerns? If anyone comes up to me and asks me how many millimeters there are in a centimeter, I might be a little frustrated with you. If anyone asks me how many centimeters are in a meter, I might be just a tish frustrated. Anybody have any idea why?
Because you just showed us.
It's literally on the board. And some of you aren't looking at the board, so you might have missed it, but that's okay. All right, you guys have work time.